Hello again in a new lecture of construction scheduling, and today we're going to start talking about schedule updating. As you remember, when we discussed the time management steps, we mentioned 6 steps. The first one was activity definition, the second one was activity sequencing, followed by resource estimating and duration estimating, and then we have schedule development, and finally schedule control. So far we have talked about maybe 5 of these steps, which ended up with schedule development, where we have managed to develop a schedule, calculate the early start, early finish, late start and late finish, total float and free float for the different activities. And now that we have a schedule, we have to put it to work, and we have to see whether it's feasible or not. And we have to maintain and update the schedule. As we have already mentioned in class, we have, while developing the schedule, we have to develop a schedule maintenance or management plan. This schedule management plan basically says how often are we going to update the schedule, how are we going to update the schedule. In some cases this is mandated by the contract, where the contractor has to submit at the end of each month with the progress report an updated schedule reflecting the current status of the project. And in some cases the contractor would take that initiative on his or her own, because they want to make sure that the schedule that they have developed is feasible and practical at the same time. And they want to know at each point in time, at any point in time, where are they compared to their baseline or their established approved schedule. So the topic today that we're going to talk about is how to update the schedule and keep it in a proper shape. So schedule development serves 2 major tasks. The first one is planning and control. So we want to know what are we going to do, and then while we are performing the project, we want to know whether we are doing it as planned or not. So that's the planning and control aspects of schedule development. In time planning, schedule is developed to establish a baseline or benchmark to be monitored and controlled during the project execution. This is what we're going to call the baseline schedule, which is going to be an approved document. Once it's approved by the owner, it becomes sort of a contractual document that the contractor and the owner are going to be bound to. So in project control, the actual performance is compared to the baseline, and once we make that comparison, which is what we call control, monitoring and control, we're going to monitor the progress, and then in case of any deviation from the plan or the baseline, we need to know how much is that deviation, why did it happen. We have to analyze the root cause and find out solutions, and try to make sure that the problems that occurred in the past do not keep perpetuating and repeating themselves in the future. So the scheduler compares the actual performance with the baseline performance to discern any deviation, not just for preparation and presentation to the owner before commencement of the work, and not just as a satisfaction of contractual requirements, but primarily to keep the project under control and maintain its major milestones to make sure the project is not slipping gradually. So in case of deviation from the baseline, and this is almost always going to happen, I have personally not seen any project finishing exactly as planned. There's always going to be some fine-tuning to that plan. There's going to be some deviation from the plan, whether it's based on uncontrollable conditions, which is what we called in class force majeure, or something beyond the control of all the contractual parties, or it might be due to some mistake or fault due to action or inaction by any of the contractual parties, whether it's the owner, the contractor, or the architect engineer, the construction manager, subcontractors, and so on and so forth. It could be unexpected soil conditions, it could be inclement weather, it could be equipment breakdown, so many different factors that can lead to deviation from the baseline schedule. So the project manager needs to know where is the deviation, in which activity or which set of activities, what's the cause of that deviation, whether it's the schedule initially was defective in its initial assessment, or the performance did not match the expected production rates, for example. What is the magnitude of the deviation? Again, if we're talking about a 3-year project and we have a deviation of 3 days, no big deal, we can recover that very easily. But if we're talking about a project with a 6-month duration and we have 3 weeks of delay, this is really considerable. So once we analyze the deviation and we know its magnitude, what's the required corrective action to be taken? How can we correct that mistake? Is it through filing a claim for time extension, for example? Is it through acceleration of work, working another shift, or using bigger equipment, using additional resources? what kind of preventive action should be taken to avoid the repetition of the causes of that deviation, just to make sure that we do not repeat the same mistakes, and what is the end forecast. If we keep progressing at the same pace, are we going to be able to finish on time? If it's a non-critical activity, are we within our float so it does not affect the schedule? If we are in a critical activity, then definitely it's going to affect the schedule. And most importantly, which is what you can carry from one project to another, is what are the lessons learned. So this graph shows basically the project control cycle, where we start planning, we develop the project objectives, we implement the project and keep monitoring the performance, and then we measure the progress on a scheduled, frequent basis. And then we find what the root cause is of any deviation, if any, and then we implement the controls, whether it's corrective action or preventive action, and then we update the project objectives, and then we repeat the same cycle again. We do that on a weekly basis, bi-monthly basis, monthly basis. We need to keep doing that as long as the project is progressing. Control means not only monitoring. So monitoring is observing and measuring, but what is the result of that monitoring and observing? It's the decision that we're going to make. So it's taking the corrective measures whenever and wherever necessary. To control is to compare, so we have to have a baseline or a benchmark to compare to. We have to have a fixed target, and then we have to have a moving object, which is the schedule under progress. We have to compare that moving object to the fixed target to know exactly how are we performing. So the baseline is also known as the target schedule, as we just mentioned, and it may be different with as planned schedule. So we keep updating that basically due to contractual changes, for example, that have shown after we have signed the contract and things like that. It's going to be prepared by the general contractor usually to incorporate all the schedules developed by the subcontractors and suppliers, and it has to be developed before the start of the project, because as we mentioned, in most of the cases this is going to be a contractual document that everyone is going to be using in the future. It's going to be used for performance comparison, and if approved by the owner, it becomes a part of the contract documents. The updated schedule is the schedule reflecting the actual performance information. So this is not the target schedule anymore. Now we're talking about the moving object, that vehicle that's moving along the project completion. It includes the time of occurrence of different activities, amount or percentage of work completed, what we call the PCT, and changes to future work. So as a definition, a revised schedule reflecting the project information at a given data date. That's the data date, the measuring date, where we're going to measure our performance and decide how we're doing regarding completed activities, in progress activities, and changes in the logic, cost, and resources required and allocated at any activity level. It reflects the actual start and finish dates for activities, as well as their percentage of completion, PCT. So these are at least 3 pieces of information that we need to collect during the monitoring process. For the activities that have started, what was their actual start? If the activity is complete, what was the actual finish for that activity? And if the activity has started but it's still in progress, it's not complete yet, what is the percent complete or the percentage of completion of that activity? And we're going to see different ways of measuring that percentage of completion. So the data date is also known as the as-of date, schedule date, status date, update date. All of these are the same things, talking about the same concept, which is the date as of which all progress on the project is reported. It is not the current date or the time now, because, for example, today might be March 10th or March 9th, but I base my schedule on an update on, or a cutoff date on March 5th, for example. So some of the required information that we need to collect are the actual start, which denotes the actual start date of the activity obtained from the construction site or from the key performer of the activity. If it's done in a shop by a subcontractor or supplier, they're going to provide us with that actual start. And the actual finish denotes the date by which the activity is considered to be complete, whether it's substantial completion or practical completion. This is something to discuss a little bit later. PCT, or percent complete, which applies to activities that have an actual start. If it has not started yet, then the percent complete is 0. If the activity has already been completed, then the percent complete is going to be 100%. OD, now we're going to talk about different types of duration. So OD is the original duration, which is basically the same duration that we have calculated in the past, which is obtained from Q over P in deterministic scheduling or the PERT equation in probabilistic scheduling. Elapsed duration is a part or a portion of that original duration, which is the amount of time that has elapsed since the activity has started. Denotes the portion of the activity duration that has elapsed since its start. And there are different methods for measuring the elapsed duration. The one we will use is elapsed duration is equal to original duration times percent complete. That's why it's very important to know and to accurately measure the percent complete. And we're also gone around to the nearest day, basically, or the nearest increment, time increment. So if we get, for example, 5.1 or 5.6 or 5.9, all of these are going to be rounded up to 6 days. And finally, the remaining duration. Okay, the original duration was, let's say, 10 days. The elapsed duration was 6 days. Therefore, from the original duration, we have 4 days left to complete that activity, and this is going to be what we call the remaining duration, which denotes the remaining portion of the activity duration not yet utilized, and calculated through a very simple equation, which is remaining duration is original minus elapsed. So to update the schedule, you need some past information, historical information, like which activities have started in this updating period, and for these activities, what was the actual start date, what is the percent complete, and the remaining duration for each one of these activities. And then for the activities that are complete, what was the actual finish date? Of course, the percent complete is going to be 100%. And the actual budget spending or resource consumption for each activity, because in many cases we're going to find activities that are driven by the resources, the availability of resources. So if the resources are not available, then the duration of the activity might be extended. Future information, so the updating is not only a statement of the past, but it's also a projection into the future. So for future information, we need to know if there are any activities that have been added since we have approved the baseline schedule, if there have been any activities that have been deleted, activities that have been changed in duration, logic, budget, resources, constraints, or otherwise, again, in response to corrective actions or preventive actions, any change to the imposed finish date for the entire schedule or the constraint date for certain milestones, whether this is through an excusable delay, which is an extension of time given by the owner for some delay beyond the control of any of the contract parties, and so on and so forth. And finally, any schedule-related but not activity-specific change. So cost, availability of resources, calendar work days. If, for example, we're going to need to work 6 days a week instead of 5 just to recover some of the delays that we've had in the past, how is that going to affect our budget and our total cost and so on? If we add an activity, for example, how is that going to affect our logic? So if we add activity C as it appears here in this graph, activity C has been inserted. So we need to detach activity A from D and B from E and connect A and B to C and connect C to D and E. So we're going to change the logic that links the different activities. We might add lags or overlaps and change the types of relationships based on activity addition. So the scheduler should review the logic before making any changes, printing the logic report showing all predecessors and successors for the activity to be deleted. If we're going to delete any activity, just to know which activities are going to be impacted or affected by that deletion. In some cases, adding an activity may create a redundancy problem. So for example, we had originally E as a direct successor to B, and then we added activity C and we linked activity C as a successor to B and E is a successor to C. Right now we don't need that link anymore, the link that's between B and E, because this is redundant. It doesn't have any meaning whatsoever, so we can cut that link. We're going to exercise in class on manual schedule updates, and we're going to have an assignment or an example, solved example on that as well. So, for example, 10 days after the project has started, you receive a following report. This is a typical report that you may get from the site. to tell you about the progress of the project. Activities A and B are complete, so PCT is 100%. Actual finish of A day 2, actual start of B day 2. If we look here, so A ended on time and B started on time. Actual finish of B day 9. Now we notice here that B was supposed to finish on day 8, and now it had finished on day 9, so obviously activity B is 1 day behind schedule. C started on day 2 with a remaining duration of 2 days. D started on 2, duration 4, remaining duration 0, which means it's complete. Duration of activity F was adjusted to 4 days. Activity E has been cancelled. P is added, durations 5 days, etc. So you can see different changes to the schedule based on the regular updates. How is that going to impact my schedule? This needs to be calculated. So how are we going to follow the procedural and systematic steps to update the schedule? The project manager is going to prepares a list of actual progress, changes for individual activities, and all related information, and that can be done in a tabular form. So it's going to be recorded on a daily basis, which activities started, which changes have been made to the logic, and so on, which resources have been added or removed, and how is that going to impact the schedule. The scheduler is going to feed that information collected by the project manager into the computer scheduling program and update the schedule. Remember that with computers, garbage in, garbage out. If your data is correct and your method is correct, you're going to get correct output. If your method is incorrect and your software is fine, you're still going to get the wrong output. And if your data is correct and the software is not working properly, you're still going to get the wrong output. The schedule is going to communicate with the project manager to inquire about any missing information or any clarification that they might need. And then the schedule is going to print new reports that show the updated schedule and deliver them to the project manager, who is going to, through the progress meetings, distribute them and disseminate them to the relevant parties. And they're going to receive feedback from the project manager. The schedule is going to receive that feedback from the project manager and wait for next updates. Again, this is going to be done on a very regular basis. The work progress affects both schedule status and progress payments, because again, you are going to be paid based on the amount of work that you have done, which you have to report to the client, to the owner. So it's very important to measure the work progress in an accurate way. You have to calculate or estimate the percent complete for each activity and estimate the percent complete for the entire project. And we're going to see an example on that in a moment. So the Construction Industry Institute, which is a think tank for the construction industry, including all the big contractors and all the big clients in the US, and that's a huge organization that does research on construction and construction management. It has identified through best practices 6 different methods for progress measurement. And these methods are, the first one is units completed. So for example, if my activity is to install 70 air handling units, and I have installed 49 of them, so 49 divided by 70, that gives me 70% complete. So basically I can say that the activity is 70% complete. So the percent complete is units completed over the total units. Method number 2 is cost or time ratio. Activities that are continuous and uniform throughout the project. Time ratio is going to be time elapsed divided by total duration. So if I had an activity with a duration of 10 days and 6 days have elapsed, then that activity is 60% complete. And similarly, measuring by cost. If I estimated a cost for this activity as $10,000 and I have spent $4,000, then this activity is 40% complete. So it's cost to date divided by total budget. That can be done at the activity level and the project level as well. Man-hour ratio, it's actual man-hours consumed divided by the total man-hours budgeted. Remember, when we identify the resources for the activity, we include man-hours for labor resources, equipment hours for equipment and materials, and so on and so forth. In some cases, the human factor or the equipment factor are going to be the driving or the controlling factor in the duration of the activity. So in this case, if for example I estimated this activity is going to take 200 man-hours and I have already used 120, then this activity must be 60% complete. That's the cost or time ratio. Another method for measuring the progress of the activities is all or nothing. So if the activity is complete, I'm going to give it 100%. If it is not complete, it is 0%. So if it has not started, 0%, started but not yet finished, either I give it an arbitrary amount or just give it 0, or wait until it's complete, and then in this case I'm going to count it as 100%. And this can be very useful only for very short activities with a very short duration. Another elaboration on the all or nothing is the incremental milestones. If I have, for example, a large slab on grade, and in that slab on grade I have some underground pipes and cables, and I have rebar, and I have concrete, and so on, and I have curing of that concrete. So if the rebar is 50% complete, am I going to consider it 0 and wait until it's 100% to count it as 100%? That would be relatively unfair, because this might be a long activity with a long duration. So it's used for activities that contain a set of tasks or stages. I can say, for example, that once the formwork for that slab on grade is done, this is, let's say, 10%. Once the underground utilities are done, this is 50%. Once the rebar is done, that's another 30%, so it's a total of 90% or 80%. And then once I have placed the concrete, that's another 10%. And once I cure the concrete and I remove the forms, then this is the remaining amount. And that way I can measure the progress of that activity based on which subtasks have been completed. So each stage of a given activity is assigned a weight that's approximately equal to its percentage share in the effort in the total activity. Then each stage is treated as all or nothing. So if the rebar is not complete, I'm going to give it a 0. If it's complete, I'm going to give it all of the 40%, which is the weight of that rebar, and so on. So here is an example of incremental milestones. A contractor is installing 25 doors. 4 doors have not yet been started, so percent complete is 0. 8 doors had their frames erected, and we consider that the frame erection for each door is 30% of the work. 6 doors have been hung. We consider hanging the doors is 50% of the work. 4 doors after being hung have been painted, so we consider that as 75% of the work. And then the last 3 doors had all of the previous steps completed, plus the hardware also installed, which is the remaining 25%. So now these 3 doors are 100% complete. Now if I want to know what's the total progress of that activity of hanging these and installing these 25 doors, here's the example. So for the activity not yet started, 4 times 0 is 0. We can consider that the total weight is 25, which is 25 doors, times 100 points for each door, so a total is 2,500 points. So for the doors that have not been installed, it's 4 times 0, so it's 0. For the doors that have been erected or manufactured, it's 8 doors, and that's 30%. So 8 times 30 times 30, that's going to give us 9.6%, or 8 times 30, which is 240 points, compared to the 2,500 points, that's 9.6%. The doors that have been already hung, 6 doors, so again 6 times 50, because that's 50%, so that's a total of 300 points, divided by 2,500, that's another 12%. The doors that have been painted, 4 doors times 75%, which is 75 points, so 300 points divided by 2,500, that's another 12%. And finally 3 doors have been completed, and these are 300 points, because it's 100% for these 3 doors. So 300 divided by 2,500, that's another 12%. So when we add that total, it gives us a percentage of completion for that activity of installing the 25 doors of 45.6%. Method number 5 is supervisor's opinion, and that's sort of subjective, because the supervisors or the superintendents might have different opinions on the progress of the activity. They might think that the hard part has already passed and what's left is quite easy work, so they might give a higher percentage of completion. No other method can be suitably, it's going to be used if no other method can be suitably applied, only in this case. And it relies totally on the foreman or superintendent's judgment, so it's most convenient because it's easiest to obtain, but it might be the least accurate because it's, again, a subjective opinion of that superintendent, and you should not overuse it. And finally, the last method is the weighted or equivalent units. And it's similar to the incremental milestones method, although the only difference is that it does not take into consideration the order in which the activity is performed. So the major difference is that sub-activities in the incremental milestones method must occur in a chronological sequence. You cannot install the hardware before painting the door, for example. But the sub-activities in this particular method do not have to be done in any particular sequence. They can be done out of sequence. So in this case, we can use that weighted or equivalent units. So as a summary, there's no perfect method. It depends on the conditions, depends on the activity, the type of activity, depends on the duration of the activity, and depends on the experience of the superintendent, and so on. So again, the summary, the units completed is units completed divided by total units, the budget spending, similar but done with the cost, actual budget divided by total budget, man hours completed, same idea, consumed man hours or actual man hours divided by total man hours. So number 2 and 3 should be used with caution when there's a variance from the baseline because of change orders or variation orders, change of scope, and so on. We have to take that into consideration as well. The workday unit method is based on the assumption that activities have weights proportional to their durations, which is a very simple assumption. If the activity's duration is 10 days, we're going to assume that we're going to complete 10% of the activity on each day. So the weight of the duration is uniformly distributed along the duration of that activity. The workday unit assumptions, all activities have the same weight per day. The weight within activity is distributed linearly. So as we just mentioned, an activity with a total duration of 10 days will be assigned a progress of 10% for each day. Duration percent complete, the percent complete is equal actual or elapsed duration divided by total duration, the updated one, in case of any change orders or claims. Elapsed duration is equal to total duration minus remaining duration divided by total duration, which is also equal to data date minus actual start date divided by total duration. And notice here that the elapsed duration, as we have mentioned before, is going to be rounded up to the nearest day as a factor of safety, and therefore the remaining duration is equal to original minus elapsed duration. The units completed method may work for the percent complete of an activity, but it's difficult to apply to the entire project because there's no single unit in common to measure. So for example, when you talked about air handling units or doors, well, not the whole project is doors or air handling units, so units by itself is not a common factor to measure and to distribute along the whole project. Budget spending, now we have only one common unit of measure, which is dollars, for example, or the currency that you're going to be using, as all the resources can be translated into that universal or common factor. So, but what if the budget spending differs from the baseline budget? What if there have been changes to the scope which increase the budget? That has to be taken into consideration as well. Workday unit method, activities such as procurement or obtaining permits may have much more weight than they deserve. So again, we have to factor that into our calculations as well. Duration percent complete work, the only caveat here or the only caution is that work in the project is treated as a linear variable and should use updated project duration. In some cases, however, we know that the bulk of the activity is going to be done on the first couple of days, for example, something like setup and alignment and so on, whereas the remaining of the work is not going to take that long. So that also can be factored as a front loading of the weight of the activity towards the beginning of its duration. Progress payments are going to be the pay requests. As we mentioned before, one of the objectives of project updating is to enable you to submit your payment request to the client for reimbursement, and they have to reflect actual and accurate progress of the project. So the pay requests depend completely on the percent complete for each activity and the unit prices submitted and approved in the schedule of values. So steps for progress payment include: the contract specifies the frequency, how often are you going to be submitting a payment request, whether it depends on a certain duration of time, fixed duration like every month, or a certain percentage of amount of work done, let's say every 15%, every 30%, and so on. It's usually going to be on a monthly basis, and the closeout date for each period, the contract is going to say you have to submit, for example, the payment by the 5th day of the month. The general contractor is going to list all the activities that had work done on them since the previous period. We're going to say this month we have worked on 1, 2, 3, 4, 5, and these are the actual dates, and these are the percentage of completion for each activity. That's going to include the actual start, actual finish, percent complete, and original budget, cost of this period, cost to date, and cost to complete. What's the remaining cost to complete that activity? And the general contractor and the subcontractor have to concur on percent complete. So again, if you have a subcontractor that submitted this information to you, you have to agree with the subcontractor, so only 1% complete is going to be submitted, and it's usually going to be on the conservative side. So if the subcontractor says it's 75% and you as a GC say no, it's only 70%, what you're going to submit is the 70%, not the 75%. The report is going to be reviewed and verified by the owner or the owner's representative, the architect engineer, for example, or the construction manager for the owner, and they're going to check the completed quantity. They're going to ensure that these quantities have been completed properly according to the specs and they've been accepted. They're going to review the unit prices as per the bid price, and the totals are going to be calculated in the payment request. The payment request can be approved as is if there's no disagreement between the client and the contractor, or approved with some numbers disapproved. So we're going to hold on these numbers. We're going to investigate them a little more, but in order not to delay the whole payment, we're going to set them aside and give you a release for the approved amount, or totally reject it and send for resubmit if there are some erroneous quantities or erroneous calculations or disagreement on conceptual issues in that payment. It might be returned to the contractor for review and resubmittal. And the schedule of values must be updated with the cost of any change orders to reflect that the new unit price is this and not the old one in the bid. And basically this is the end of this lecture talking about schedule updating. I hope by now you know what schedule updating means and how it's going to be used to maintain the project schedule. Thank you, and see you in the next lecture.